This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to Ship It, the podcast all about what happens after you Git push. I am your host, Justin Garrison, and with me, as always, is Autumn Nash. How's it going? You're bouncing. It's great.
I'm always taking a cup of coffee and it's hitting.
Energy.
The caffeine has kicked in, y'all.
It reminds me of like old. You never had an old desktop, did you? Like a '90s desktop, like the one with a turbo button. Did you have a turbo button on your computer?
No.
Oh man, it was like the old school like overclocking. Like that was like, I mean, technically it was like the clock speed and everything else was underclocked, but like whoever turned off the turbo button. And
there was a turbo button for computer. I feel like I've missed so much. Like
yeah, no, it was good times. Like I had my first
you
computer.
Old people had all the cool stuff.
I didn't even have a computer. I had a computer in like 2000, 2001, 2002 was my first computer, but like it was a computer from the 90s. And so it was like what was the E-machine, I think is what it was.
My first computer was the iMac. It was teal.
You didn't even have, that's not even a computer, that's a product.
No, it was the cute little desktop and I was in love with it. Like I've never loved something so, like I played, what's that Descent space game and like Oregon Trail. And then I like learned what a file system was and like the nerd in me like blossomed that day.
I never played Oregon Trail. That's what I missed out on.
What is wrong with you? I have a shirt that says I died of dysentery from from the computer museum in Seattle. I'm so sad that closed down. I was like looking at it and I was like, Justin's coming to Seattle, and I was like, I'll take him to the computer museum, and it closed down. It made me so sad. That place was so cool.
Yeah, no, I remember I was probably in like second or third grade.
If we get rich, we got to open the computer museum again.
Oh, that's just gonna be my garage. I have so much old stuff in here. Like
dude, they have like a legit, like one of those like hidden figures computers in a room. It's so cool. And like every old computer, like the computers of my childhood were in there. And I was just like, and you can like play games on them. That was like one of like the oldest Linux I've ever played with. Was they had like a whole room of like just old computers and you could just try to do stuff on them. It was so much. It's like being like a nerd in a candy store, you know, like you walk in and like you're like, I haven't seen this stuff in 20 years. It's so cool.
I am on the lookout right now literally for a project to find old Linksys WRT 54Gs, like the blue.
If you find an old iMac, you better get it from me.
Oh, these old iMacs. They're like a couple $100. I actually saw one. I was at a thrift store.
And you didn't get it for me?
It was like $300.
Okay, I would have Apple paid you if you had told me about it. Because like you keep trying to suggest I get that dude's iPad cases. I was like, I could buy a real iMac for that price. Like, I don't know what I would do with it.
I have a Mac too. Like I could throw a rock at it right now.
I'm trying to think of what I would do with it. My kid has my old iMac and he acts like he's dying because it's slow. And I'm like, sir, that was like the business when I bought that. Like
733 megahertz.
I was like, just because like you live in the world of like fast processors and everything, like I had to use dial-up internet. Okay, I had to save up for that iMac.
Go get your kids a Net Zero CD. And like the free 90 minutes a month.
I am like the asshole parent. I'm like, if you want to be like a real, like you want to get into tech, you can go build your own computer. Like we're going to the thrift shop this weekend and he is going to figure out, I was like, you need to research all the like different parts of a computer and how you put it together.
And speaking of everything old is new again, this week.
It always is because good tech is simple.
Yeah.
It's simple, and then you make it better and accessible and easier to use. You don't just invent the wheel over and over again.
Old ideas and new execution.
Yes.
And that's exactly, we're talking about WASM today, WebAssembly. We have Bailey and Taylor.
I'm really becoming a fan of WASM. Like I was not, like I didn't, like it wasn't really on my radar, and now I'm like, this is kind of cool.
The only times that I've used it and I've written WebAssembly, it was great because it was invisible. And that is not the case for Docker and containers, where you like it's part of your deployment pipeline. And like as a compile out a WASM binary and then stick it on a runtime, it's been great. It's just like, oh, I don't have to think about it.
I'm trying to figure out how I get into Kubernetes, and I really want to play with Terraform. So I'm like, maybe WASM will be how I get into Kubernetes. I mean, I use Docker all the time, but you know what I mean? Like, I don't know, y'all with Kubernetes, like y'all just be like, I want to touch all the things and like do all the things and make this as complicated as possible. And then like just looking at the like Cloud Foundation like website just scares me. Like,
yeah. I just this last week wrote a 10-year Kubernetes blog post and like going through my history of like what I've done with Kubernetes, because I've been working with or around Kubernetes for like 9 years now. And I'm like, I don't know like 80% of the stuff. Like you don't touch everything in the stack. It's like if you're trying to go down that route, you may be looking at too much stuff and you really have to focus. And WASM feels like it focuses more on the application. It tries to simplify some of the other stuff, but we get into it really deep today with Bailey and Taylor, both from WasmCloud, who laid out a lot of cool things that we got to talk more about, like the bytecode foundation and just in general, like how the W3C is attacking the WASI interface, WebAssembly System Interface. I'm trying to remember the acronyms now, but she said it changes. It's in the interview. Listen for it, because now it's not System Interface anymore. Standard Interface. That's what it's called.
It's really nice to talk to like open source communities and open source practitioners that are thriving, because open source feels real dark right now, you know, like, so it's nice to see like the Postgres community and like WASL and like WebAssembly community, like they all seem like they're really making good progress and solving problems and having like they're gaining traction and kind of like, you know, doing well. So it's really exciting to see that they're solving problems and just, you know, doing good stuff, because it seems like that is a very nice, accessible way to get into Kubernetes possibly.
So let's jump into the interview, and when we come back, we will talk about some more old technologies.
Well, friends, I have something special for you because I made a new friend, Tamar Ben Sharkar, Senior Engineering Manager over at Retool. Okay, so our sponsor for this episode is Neon. And as you know, we use Neon, but we don't use Neon like Retool uses Neon. Retool needed to stand up a service called Retool DB. Tamar can explain it better in this conversation, but Retool DB is powered by Neon. Okay, they have a service called Fleets. It is a service that manages enterprise level fleets of Postgres, serverless managed fleets of Postgres. And Retool DB by Retool is powered by Neon Fleets. Okay, Tamar, take us into how Retool is using Neon for Retool DB at large.
So one big problem we had with Retool, we wanted users to have value, production value as soon as possible. And connecting to a prod DB in a new tool is not something that people will do lightly.
No.
But they're much more likely to then dump a CSV into Retool. And so because of that, we said, okay, well, what if we just host databases on behalf of users? And then they can get spin up really fast. And we really saw that take off. Problem we had is we didn't have a big team. We couldn't spin up a new team to support this feature. So what do we do? And so we were looking, okay, what are the options out there? And we found Neon. Neon is a serverless platform that manages Postgres DBs. And so okay, that's interesting. Let's kind of look in further. What's kind of really unique about them is you really only pay for what you use, which is exactly the use case that we have, right? Because we want to provide this to everybody. Not everyone uses it. Not everyone uses it all the time. And so if we had to us manage a bunch of RDS instances, for example, right? Basically we'd have a whole infra team to support, figure out, okay, what are they on? How do we do? Try to have some kind of greedy algorithm to get all the data in the fewest amount of instances as possible, right? This is now a hard problem. That's not kind of a core value, right? A core value is kind of providing that database. And we don't want to we're not like an infra team. We don't want to kind of get in that game. I think what's really great is that, okay, well, one big kind of risk when you think of going in third party is the cost. We're giving this free to all users. We have 300,000 databases right now, right? We can't, especially as we were rolling this out to begin with, right? We didn't know for sure how people would respond, right? And we can't all of a sudden have a couple $1 million at the bank for this without kind of seeing kind of the activation that it has on our users.
So it's kind of obvious, but what was the appeal of Neon?
What was really appealing to Neon, it spits out to zero. And so because of that, right, it really kind of reduces the cost. And so really, it's really exactly only what we spend. And there's really actually not a way to actually spend less money, even if we're hosting it ourselves. So you're like removing all like the people cost. Right? Because let's say we use something like a RDS, we have to figure out ourselves, right? Basically what Neon is doing, right? How to bucket all the instances together, how to bucket the usages to have as few instances as possible, right? To scale up and down depending on what's going on. And now we sort of don't have to worry about any of that part, but still get kind of the cost benefit. And so really kind of was out, it's a win-win.
Okay, win-win. Always a good thing. I like win-win-wins, but okay, fine. Win-win. If it were not for Neon and their offering of fleets of Postgres and how they're essentially your serverless Postgres platform, where would Retool be at with Retool DB without Neon?
Oh, we would have to have at least a fully staffed team. On-call burden would be a challenge. I think we have to spend a lot of time on, making it sustainable. And that's, a whole, other sets of concerns that we don't have to think about. First of all, it's a team of engineers, right, which is not free. So everyone's salaries, right? So let's say probably a team, 8 to 10 people, easily only focus on this. And then it's saying, okay, well, does the revenue of Retool DB offset the cost, even of just the engineers? So, that's step one. But I think even before then, right, you'd have to set up this team before you even had the product. Databases and, having them the way that Neon has them, right, suspend to zero, having, warm spares that they're, ready instantaneously when you log on to Retool, those things aren't free. And even if we tried to do like an MVP, right? There's the kind of basic functionality that needs to exist that we all have to start from scratch. And that would be a huge commitment to this. And I think we would have it would come out a year later because we'd have to do a lot more validation to know that it would have been worth it right before we started. Here, we were able to quickly try it out, see that it was effective, and then grow it from there because the cost was very low. And that really gave us a lot of flexibility of also testing out different features and different flavors of it.
Okay, so Retool DB is fully powered by, backed by, managed by Neon. Neon Fleets, neon.tech/enterprise. Learn more. We love Neon here at Changelog. We use Neon for our Postgres database. We enjoy every single feature that Tamar mentioned for Retool DB, but we use it at a small scale, a single database for our application. They use it at scale. One single engineer propped it up, manages it. That's insane. They would have never been able to do this without Neon. Retool DB would have cost more and may not exist without Neon. Okay, go to neon.tech, learn more, or neon.tech/enterprise.
Today on the show, we have Bailey Hayes and Taylor Thomas. Bailey, you are the CTO of Cosmonic and a co-chair for the W3C WebAssembly System Interface Group. And Taylor, you are Director of Engineering at Cosmonic and the co-chair of the WASM Working Group for Kubernetes. Is that right?
Yes, that is correct.
I got at least part of the titles good, so this is great. This is a good start now. Bailey, we first met a couple years ago at KubeCon. I was wandering the KubeCon floor, and I was trying to figure out this WASM thing, what is WebAssembly? And I went to a couple booths, and it wasn't really explained really well to me. I remember stopping at your booth and talking to you, and you were so excited about WASM and what it could do, especially for developers and applications. And then mostly around that, abstracting away all the little details behind how an application plugs into the rest of the stuff. And it's been a couple years now. Can you describe a little bit of what you've been working on and what WASI specifically is for how applications fit into this ecosystem of products?
Yeah, I think at the time we were very much underway on developing the component model and this next iteration of WASI.2. That was several years' effort that we delivered on January 24th is when I held the vote in the WASI subgroup. And so that was when we officially launched it. And that's a pretty big difference from the last time we talked, where people like me were so excited and evangelizing it, but because we needed people to come in, we needed more hands to make it real. And now where we are is that folks are able to build with their standard language tool chains, and many, many different ones are underway or actively have already been delivered. Some of the ones I'll call off that are most recent is the TinyGo work has landed it where I just write normal Go code, and all of those normal syscalls that I might make when I target WASI P2, out comes a .wasm that is interacting with those WASI interfaces. We probably should describe what those are, since that's very tight to my role, but the short answer between when we talked before to now is that it's very real, y'all. And people are building on it. We have customers and real use cases and deployed into production, which feels great.
If you've never heard of like WebAssembly, let's say that you were a customer, what would be your use case to switch or to try to build something in WebAssembly?
Yeah, so I would say that the most people that are coming to the party are large enterprises that have a fleet of microservices. They're feeling the pain of having to maintain those over time. They're feeling the pain of, from cost to even maintenance complexity. And they're looking for a solution that is not just a smaller container, but something that is based around a contract-driven design so that you can easily swap out the provider side of things. So if you're a platform engineer, you feel this problem extremely acutely, that you want to update the client that everybody is using because you want to update the database that everybody is using, or you want to update the messaging provider that everybody is using, like Kafka, and you just can't do it because that requires the entire fleet of developers to go and rev this stuff. And the way that it actually looks in the real world is it's a giant human build chain to actually be able to make these changes. And by decoupling that and by working at a different level of abstraction, the developers focus on what they want to focus on, just writing their business logic. And then the platform engineers are able to provide a platform that decouples that and that they can easily maintain. Those folks at those large enterprises are really into it. Of course, that scale goes all the way to the people who recognize that WebAssembly is the next abstraction that is safer, smaller, faster than all the things that came before. But for enterprises, it's usually that bottom line that's the most important to them, which they're feeling.
Does that abstraction limit what you can do with the tools? Like if I say I have Kafka over here and something else that's another message bus, like at some point I just have to go to like the least common denominator. I can't use the power of Kafka because I'm like, oh well, now I have to treat it like a generic thing, and I don't get the benefits out of the choice I made for that technology.
Yes, absolutely. And we have Taylor Thomas here, who's on the champion on a lot of the WasmCloud interfaces. And that is very much their motto. I'll let Taylor give it.
Yeah, the WasmCloud interfaces are a set of these things like you're talking about, where we have this idea of, okay, we have a lowest common denominator. And part of the work that we do inside of the WebAssembly working group that's part of Tag Runtime in CNCF is we help provide feedback for these interfaces. Now, what's really nice about these interfaces, and the reason they're called components, is because you can actually compose them together, and you can choose which interface you get to opt into. So one of the key benefits of WebAssembly is this isn't like the Corba kind of old style of interface things where you're locked into a specific kind. The WasmCloud interfaces are aiming to be those lowest common denominator. The 80% use case is what we generally call it over there, which is the common term a lot of people know. And we aim for those, right? Because there's a lot of people who just need that. And you see that in any of like the cloud providers. You see it from everything like functions as a service providers like Cloudflare Workers to more complex things in the major clouds where they have like some standard sets of features that you can just kind of get and attach. And so you can opt into that. And the goal we see for the future here is, let's say you have, like a Kafka, like you'd mentioned, and you have a messaging, which is actually one of the interfaces I'm actively working on right now. You're going to have the basic messaging things that you need from that, but you might not support all the Kafka features, and that's fine, because what happens is for those more simple applications, which it's called the 80% use case for a reason, right? It's 80% of those applications. Those things can be extremely portable. But when you start to talk about more of these performance issues, you can either compose it with another type of interface or select a different interface. So you can have what we see in the future here. We're already seeing this now, actually, is you have something like these base interfaces, and then you have the Kafka specific interface. And so when you're making these decisions, you're very clearly opting into a specific library or database rather than getting coupled at the very, very beginning of the work that you're doing, which allows for a lot of flexibility. And because these things are just essentially things that plug together, you have one end that matches the other end. Now you can actually use that to compose different things. You could say, oh, I'm going to update this interface, or I'm going to improve it. And you can put something that's basically an adapter between it without needing to go update your original code. So it leads to a really interesting process with software development.
So it adds the portability and ease of adoption for like, hey, if I fit this model, I can now change out my cloud, right? Like this, like that portability is really nice. But at some point, I probably need some specifics depending on my application. Not every application does, but is this similar to something like I was just doing Python yesterday, some SQL alchemy versus like the database like specific driver in Python. Like I can have this generic interface that does a lot of things, but it makes some of the complicated things really messy. Or I can go into the database specific things and it's a little harder to get started and it's not portable, but I can do anything I want.
Yes, absolutely. So WASI started as the WebAssembly systems interface, but really now it's very much the WebAssembly standardized interfaces. So we're going through and finding that common set, or really it's most often the case that there's already some standard API or interface that already exists. I'll use libUSB as an example. So we've been working on WASI USB. That is very much let's come up with a WebAssembly native way of describing that interface that makes a lot of sense and allows for capability-driven security interfaces. However, there are a lot of cases where people need a specific thing that they're doing. And so in high performance use cases for SQL contracts, that's the most common one, that people actually need exactly that thing. And in WasmCloud, Taylor and I are both maintainers of WasmCloud, which is a CNCF project. It's moving into incubating likely soon. There we are... we propose WasmCloud Postgres, which enumerates the entire set of types inside Postgres. Everybody uses it. It's easily the number one database that's at play in the open source space today. And there we came up with an interface that we think is highly optimized for it. There was previous work on, can we come up with a WASI SQL style interface that can just use kind of a lingua franca of SQL and hope for the best by passing strings and kind of just basically creating a SQL socket is all we gave people. And that very much loses out on the promise and all the work that we did in the component model to be able to provide semantic and static high-level type information for people when they're building. And then you just lose all that and give them, So the answer is we are focused on WASI Cloud Cloud stuff, which is the 80% case. We have some that are very, very optimized for a specific use case at even a hardware level within WASI. And now there's this third case that WasmCloud enables. We call it bring your own components, but essentially it allows us to support custom interfaces. So write your interface for your provider that you want, write your own provider, so you can write your own custom provider. Let's say if we don't support it, but there's a good chance that we already do, then that can be very optimized for your use case. The place where we're seeing that a lot is for people who have their own maybe proprietary providers that are a very specific data store that they're using and a very specific way of perhaps doing things like pagination. They define a WIT interface for that, which is the WebAssembly Interface Types, IDL. So they write a semantic API for it that's driven for talking really easy between WebAssembly components. And then they can have lots and lots of different WebAssembly components that act kind of like a microservice that is able to communicate with that now. That's one of the coolest things that I think we provide in WasmCloud. And the way we do that is pretty neat. But all of it at the end of the day is enabled by the standards, by WASI and WebAssembly component model.
What are the bring your own components? What is that written in? Is that more, do I write WASM to get a component? Is that like, I need to, how does that work?
So it's actually really interesting. One of the things that's hard for when people first encounter WebAssembly is they think it's something they have to learn. What you have to learn is actually the idea of interface-driven development, that WIT IDL that Bailey mentioned. But WebAssembly is just a compilation target. And so as WebAssembly matures, people will know, I think, less and less that they're actually doing WebAssembly stuff when they're compiling it down. Right now, you have to know about those kind of like things that are like up to date and have the right tools because it's a newer technology. But that's quickly going to fade into the background. And so when you bring your own components and bring your own interfaces, what I want to make really clear here is everything that you do with these interfaces is entirely standards compliant. If somebody else implements that same interface for you somewhere else, and you first created it in WasmCloud, it runs over there. That's kind of the core ethos of our project, is everything must be based on and use the standards. And so any language that can compile to WebAssembly, you can use that to write these components. Some languages are better than others right now, but that support continues to get better and better for all the different languages out there. And then the providers are actually, inside of the WasmCloud context, can be native binaries, because there's some things that can't be done in WebAssembly yet, or need like capabilities that aren't necessarily available through that. And so they are written as basically plugins for what we call the host, the WasmCloud host. It's for those familiar with Kubernetes, which are probably many of your listeners. Essentially, a host is like your kubelet. In a sense, it's the thing that runs the stuff for you. And these act as host plugins of a kind. We call them providers because they provide functionality for one thing to another. And those can be written in whatever you need to, and it conforms to specific standards. Even the way we communicate when we do things in a distributed way is over a protocol that's entirely open source and built on the standards of WIT and how WebAssembly encodes values, all of those kind of details. So it's built on top of that as well. And so all that it needs to do is use those same interfaces, no matter if it's being a distributed thing, which is what we do very well, or if you're running it just like locally with a simple tool chain or a simple tool like WasmTime, which is the CLI library.
So I can write a provider in Bash.
You could totally.
I have seen it.
Just making sure. This is always where I start.
But maybe don't.
It's wild.
So I've heard Wasm be described a lot as something like Spring for Java.
I could see that.
So is it kind of like a framework that helps Kubernetes or containers be more digestible and easier to use? Like, how would you, like, if you were not as experienced in the Kubernetes space or like containers, how would you explain that to someone who wanted to get into the space but was looking for a way that would make it more accessible for their engineering team or their organization to use, and wanted to use what you guys have built to get more experience or to find their way into containers, I guess?
I would describe WASI as sort of the model layer of MVC of what Spring Boot enables, in that it's sort of a little bit lower. It's one piece of that puzzle, not the completed piece. The implementations of it are in the Bytecode Alliance Foundation, for example. I'm TSC director of the Bytecode Alliance Foundation. It's a nonprofit for implementing secure runtimes and tooling on top of the WebAssembly standards. So we do drive a lot of use cases, a lot of production use cases, and then feed that back into the standards body, which is in the W3C. But the Bytecode Alliance itself doesn't create standards. And one of the runtimes that we have is WasmTime. And so you could consider WasmTime being the piece that facilitates the JVM part here in that story. And so that's the WebAssembly runtime. Inside the WebAssembly runtime, we have some host built-in pieces that we call essentially providers that provides an implementation of some of those WASI interfaces, like WASI HTTP. So how do I make an HTTP request? How do I respond to a request? So both the client and server side of it. Then there are entire ecosystems that are built around runtimes like WasmTime, which is, for example, WasmCloud. We embed WasmTime into our WasmCloud host. That is where we get a lot closer to that completed Spring Boot story, where with WasmCloud host, you have the MVC side of this, where our WebAssembly components are triggered in an event-driven architecture. And when they are triggered, we launch them inside WasmTime. That is done in a serverless way, in that components solve the cold start problem that a lot of Java microservices, they take a long time to start. Sometimes at my last company, some of ours took minutes, which was pretty terrible. Whereas WebAssembly components, they start in microseconds. And not only that, we're able to ahead of time compile them and cache the compilation. We're also able to streaming compile components, so it's really wonderful for distributed use cases, and they're significantly smaller. So my case at my old company, some of our Spring Boot microservices were 8 gigabytes, whereas with WebAssembly components, they're typically kilobytes. Some are megabytes, depending on the language that you compiled from into WebAssembly. But if you're building with something like Rust or C++, that's a lower level language, it's going to be very small. It's perfect for that use case.
Is Wasm still typically function based. I mean, it's short-lived runtime, right? Like, because I always hear the fast startup time is like this huge deal for WASM. It's like, oh, it's great, we can start in microseconds. I'm like, well, it doesn't matter if I only start at once, right? Like, if I'm not auto scaling all the time, if I'm running a traditional web service, I don't care how long Apache starts, right? Like, it's okay. Like, it'll take a little longer. But it seems like every use case that I've heard of with WASM is always focused on that. This is writing more of a Lambda style interface for things. So the functions as a service.
Yeah, that's a great thing to point out, Justin. And that's something that we always talk about. So if you want to run a Lambda functions as a service, we're great at that. But we also are pretty much architecture agnostic. We personally have run microservices on top of it. We've done long running things. We've done shorter running things. The main purpose is that our architecture is event driven, but it does not force you to a Lambda style thing. And so what we end up with there are stateless components that run that connects generally through these providers to access state. And then you have stateful components, which are providers. And then as WebAssembly continues to mature, some of those providers, instead of being native binaries, will just be WebAssembly binaries that are longer running. That was one of the things we gave feedback on.
But it's still event driven.
Yeah, it is event.
How does a long running process with event driven? I mean, is this just like forwarding the requests? It's always there accepting requests, but then as they come, it just triggers the event?
Yes.
Inside WasmCloud, yes.
Okay.
There's a very popular protobuf API for long-running requests that we've sort of taken inspiration from and modeled within the WasmCloud ecosystem for that type of thing. However, I will say that one of the key benefits and one of the reasons why people are so geeked about serverless-style WASM, FAS-style WASM, is that when we look at the fleet of microservices, they're not called all the time. Right? That there's just, you're spinning compute, spinning RAM when you don't need to. And a lot of those workloads deeply benefit from a really small refactor over to WebAssembly. And that saves on cost.
One of the things I was trying to get to was I've been defining the WASM ecosystem or WASM specifically for WASI specifically for like system interfaces to myself. This isn't talking about actually like WebAssembly in browsers, right? Like for the system infrastructure, microservices style stuff, I've been defining it for myself as like the Kubernetes of Lambda, right? We're having this moment of like, there's this open source ecosystem growing around event-driven architecture. Specifically, that's the architecture. It's you can do other things with it, but having it as like this open ecosystem, part of a foundation and allowing multiple parties to be involved and multiple language to be compiled, and then solving some of the underlying system stuff of like, how do you connect to something? How do you do service discovery? Like, all that's handled for you, right? Like that's handled in Kubernetes today, and it's at the Kubernetes API level, somewhat portable, but for the application, it's not. And it's very much specific. And so now my definition for myself has always been like, oh, well, now we're doing that at one level up and saying the application's a little more portable. I don't care, what database I'm calling or what event bus or those sorts of things. And I can say, oh, I can change my architecture, but you could do that in Kubernetes too. And so that's how I've been defining it. And I'm curious if that seems right, roughly right, or where I'm wrong.
It's so close. I would say that WasmCloud is the Kubernetes Lambda that you're looking for, because what all of these other projects that exist in the ecosystem that help WebAssembly run well on Kubernetes, which are awesome and cool, are missing one key aspect here, which is the WASM native orchestration that needs to happen. So right now they leverage Kubernetes service style, routing. How do I know who to talk to and that sort of thing? They typically will have like the service abstraction there in place to do that. But that really loses all of the amazing stuff that we put into the WebAssembly component model and doesn't take advantage of interface-driven design, understanding how to run that workload, that itty-bitty workload right next to where the user is. So with our operator that we run, that is all done over interfaces. And we natively scale all of this out. And actually, I feel a little silly saying it because Taylor here actually created what we call WADAM, the WebAssembly WasmCloud deployment manager.
WADAM? This is great.
WADAM, yeah, we say it like a punch. Yeah, go ahead,
say
Taylor.
It like a punch. You can see it in the logo. If you look at the project, it looks like a punch from a like a comic book.
I love whoever did the naming for WebAssembly. Whoever did the naming, like chef's kisses. Like
we have a little too much fun with the W's. We'll just say that.
Can you describe the back end of WasmCloud? When we had Fermion on, they let us know it was like, it's EC2, it's auto-scaling group with Nomad. And it's like, that's great. Like they shove everything in that and they can run thousands of functions or executions per node. How does that look for WasmCloud? Is there like, what are the differences, or what kind of design decisions have you made?
Actually, this is like our bread and butter about what we love, and kind of backs up what Bailey was saying about why we think WasmCloud is really that next Kubernetes. Because an important thing to note here before I dive into that, because this provides important context, is that Kubernetes is an infrastructure tool at its heart. It's not an application platform. It's great at running compute. It's great at running things. It's really not great for applications themselves. It doesn't offer building blocks for applications. It offers building blocks for running things. And so that's what the component model offers, is building blocks for applications. And that's what you see a lot of people at companies who have been doing Kubernetes for a while, they're getting into. They're using stuff like Backstage and they're really cool tools, but they're like resorting to templating to making sure that all of this is the same. And so when we approached it, we're like, okay, we need that, like Bailey said, this orchestration layer that sits on top. And so we tried to learn a lot of things from what Kubernetes did well and what it didn't do as well as we created this. So how WasmCloud works under the hood is we're built on top of another big CNCF project called NATS. NATS is essentially our networking layer. And the best way I've ever heard this explained was actually somebody explained it back to me after I explained them what we did, and I've used it ever since, was that NATS, when we use it that way, instead of having a dumb network and smart clients, you have a smart network and dumb clients, is the way they explained it back to me.
Sounds like an enterprise service bus.
Yeah, it kind of like I always hate saying like enterprise service bus because it makes everybody like cringe, like, oh no,
how much soap is there?
Yeah, how much soap is there? Is there an XML envelope? Anyway, so like the whole thing with like NATS is that it has those smarts, because everything, you don't have to worry about service discovery. You're using a message bus to address things to where they need to go. And so we build on top of that with our WasmCloud host. And our WasmCloud hosts together provide a very simple API for basically, it's a command and control API for starting things or stopping things or linking things together dynamically across our distributed basically cluster that we call a lattice. So that's how WasmCloud itself works. Now, in and of itself, doesn't have any smart routing. But what we didn't want to do is have the same problem that Kubernetes does, where the Kubernetes API, I mean, I know there's separate components underneath. We can always dive into that. But like essentially the Kubernetes API is the thing that orchestrates, the thing that schedules, and so like it's all one big monolith, and doesn't allow people the flexibility to really add things on without having something that adds directly onto the API. And so because we publish events off of everything that happens, you're able to key off of those. And we built WADAM, which we mentioned. And WADAM is the orchestration layer. We use the OAM manifest format, which is an open format from the CNCF as well. And we define like, here are all my different components. And here, you think of it kind of like a Kubernetes deployment. I can target these nodes or these things, and I need it to run in these regions. And all of this isn't stuck on a single Kubernetes cluster. It could be across multiple Kubernetes clusters. It could be across a custom data center or an edge and a Kubernetes cluster. It could be across multiple clouds, all being part of the same logical cluster. So when you have this WADAM, it allows you to say, I'm going to target these and spread it out and target to have certain requirements and like upper limits of how much can run. Then on top of that, for integrating in with things like Kubernetes, so that in and of itself, those things you can spin up and run on plain VMs. You can run it on Raspberry Pis. You can run it on whatever you really want to. You're not required. Our big things we're compatible with, but not dependent on any previously existing technology. So if you want to run on all these things, you can. But then we obviously thought, okay, people are running stuff in Kubernetes, and Kubernetes is great at running infrastructure. So we created the Kubernetes operator. And the Kubernetes operator, most people are familiar with operators, so I don't need to go into that. But the idea behind it is we didn't want to we're not trying to substitute out a container with a WASM component. What we're trying to do is say we want to run alongside these things you're doing. So you can install our operator into any cluster. You don't need any custom node pools. You don't need anything like that. It runs WasmCloud hosts and then actually uses the Kubernetes aggregation API to tie in to our WADAM API as well, so that you can just do kube control apply with that WADAM YAML manifest. So you can use it from the WasmCloud tooling or the Kubernetes tooling, and then it integrates in with things using like endpoint slices to be able to automatically create services to bind these together. And so we're actually, we've demoed this several times. We can always demo it. We'll always be demoing it again, of showing like connecting multiple Kubernetes clusters from multiple cloud providers all together running an application. So there's no longer this thing where you have like your DevOps workflow where you have to have 20 different copies of the thing being deployed to US East and US West, and then this region, and then this backup policy. You can just manage it as a single cluster depending on what you're doing. And those clusters can then automatically fail over because of that. Going back to the first layer, the NATS layer of this, I can just literally kill an entire cluster and things start routing to the next thing if that's running on there as well. So that's kind of the overview from like the low level to the higher level of how this all integrates in with what we currently have and anything else you want to run.
I'd describe it as a single WASM native control plane.
That's awesome, because I feel like everybody wants to be cloud agnostic right now so they can move back and forth. And I feel like out of all the conferences I've been to, it's either the same startup that nobody wants over and over again about AI, or it's like this, where it's something that's cloud agnostic, that's giving people the freedom to either have monitor and observability into multiple clouds and to be able to run infrastructure, or it's something that's making it easier to like fail over and to like have the ability to deploy on multiple clouds.
Autumn,
So,
I thought we were going to make a whole episode without AI being mentioned. I was so close.
but it's true though.
Shade, so it was,
it's true though. Like it's the same. Like I've never been so horrified on like conference boards, and I'm like, you did what?
We call that, like, being in the startup world, it's the sprinkle some AI on it strategy. And so that's what we call it.
That's not a startup thing. That's not just a startup thing. Go look at anything any FANG is doing.
I know everybody's doing it, but it's also like, that's like the strategy. People are like, we weren't sure, so we just sprinkled some AI on it and got our next round of funding or whatever, you know. So
yeah, the only difference is Google's and Microsoft's and Amazon sprinkles are a lot bigger, right? Like this is
But it's like wild. Like it was just like, let's think of like the worst idea we can come up with, and then let's put a bunch of money in it and make it like, I'm just like, this is wild. So anyways.
But back to that single architecture for your application, is that a responsible architecture? Is that something that you would recommend or should be doing? Like I've run plenty of infrastructure. Having an app that spreads regions, spreads cloud providers, spreads in trying to make it as easy as possible. Like I look at some of the really large outages in the past for any company, usually comes from this, like, I have one interface for everything and I changed the config and automatically everything fell down. Right? Like those are the types of things where the blast radius gets so large and the underlying infrastructure gets so complicated and different that I can't say the stuff running on-prem here is also in 8 different clouds around the world and I deploy it once and it goes everywhere. Like that's maybe not responsible. Is that something that is hidden or better in WASM?
I would say that it's not particularly a WASM problem, but specifically in the WasmCloud space. We designed it with resiliency in mind and global scale in mind. And the way that this essentially would work for you as doing a configuration rollout is setting a label for your specific zone that you want to do the rollout to. And you would do a gradual rollout to ensure that nothing bad happens during that. Yeah.
Yeah. At some point, you do want to take responsibility for how this works. Because the first time I was using WASM was I was building on Cloud for Workers. And I think it was great. And Taylor, to what you were saying before, like, I didn't care or know that I was writing WASM at some point. It was just like, oh, I wrote some JavaScript and then it like deployed a function around the world. And for the things I was doing, that was fine because it was for a newsletter or whatever. I'm like, I don't care if it goes down. If no one, not getting paid for it. But for like someone making money off of these things, like you want to have a little more responsibility and a little more control over making sure that you still make money off of those APIs.
Yeah.
And so to answer Autumn's original question, we were pushed in this direction because of our users and our customers. And what they needed is a way to react to this pendulum that keeps swinging back and forth. It swung hard towards the public cloud. It is now going back very hard in the other direction towards on-prem and their own data centers, or in specialized data centers that maybe are adjacent to pools and other things that are more environmentally friendly. And what we provide is something that's very much tailored to that exact use case. And now I will also say that most of the folks that are our customers, they're banks, they're telcos, they're people that you wouldn't expect using new innovative technology. that are really all in, because this is the only thing that really solves that problem well, with the level of resiliency, scalability, and really the responsibility for the platform engineering team to be able to do this safely at scale.
New innovative technologies also feels very old sometimes, right? Like this feels like a Kubernetes CGI bin, right? I mean, that's what like function as a service and event-driven architecture sometimes feels like, but making it abstracted and putting some smarts at the lower level, like put that at the network level, put that at the execution level, and then you can have some smarts about where you're routing it, how you're routing it, where your scaling is, right? Because like the network layer knows that you have multiple data centers.
What's old is new again. That is definitely the case. I mean, look, hey, I didn't say it this time, but I could have said WebAssembly. It's your write once, run anywhere technology. We might have heard that before.
Yeah, the last time, that's why we were talking about it with Java in the last interview we had about WebAssembly, because it was like it feels very similar, but with newer smarts at different layers. Like we've taken some of what we learned from enterprise service buses, we've taken some of what we learned from Kubernetes and the cloud, and we say, okay, how does this work for applications?
And we've broken it down to first principles and went back to the root of the problem, which is effectively, how do you describe what an application is? And what does an application need? And then built a platform around that.
And WasmCloud is something anyone can run themselves. Like this is
open source, CNCF project. Yeah. I think what I would tell people to do is to use the WasmCloud operator. We've got a Helm chart. It helps you deploy NATs, and then WasmCloud on top of NATs runs really well inside Kubernetes. It doesn't have a lot of the pitfalls that some of the other WASM Kubernetes approaches have, which is like you've got to go down there and modify like things like runtime classes and create node pools and all this very specialized stuff for running WASM, whereas this just 3 commands, you're running WASM alongside containers, and it just works. You don't have to really make any major changes to your platform.
Do you know how that compares to other event-driven runtimes that are more container native, like Knative? Or like Knative gives me that sort of Lambda style execution inside my environment, but it's all container based. I think they have some abstraction of like how you get executed. I haven't run it for a while, but do you know how this compares outside of just being a different binary?
Yeah, I would say footprint wise, WasmCloud is vastly smaller, and any of these other WASM solutions. But also in terms of orchestration, it has the WASM cold start versus a container cold start. So much more advantageous from that perspective. Now, in terms of like what languages can I write in and target, I think WASM has slightly more restrictions versus what you can stuff inside a container. However, 17 out of the top 20 languages have some level of WASM support, and that's growing every day. So that's very rapidly not going to be a thing that we talk about anymore.
Can you describe to me what the Bytecode Alliance does? That's been one of those things that's like on the side where it's like when I look at this portable binaries, I look at an ELF binary that I have on Linux, and I'm like, I can run this on any Linux kernel or that supports some level of C and whatever it's trying to call. Why is there a new executable formats and a runtime interpreter? It's not called an interpreter, whatever the runtime is that executes the bytecode that spits out. How does that work together?
Yeah, hey, it could be an interpreter. There's WASMI, WASM3, Whammer has its own interpreter, WasmTime's working on its own interpreter. So it's at play with WebAssembly too. So the Bytecode Alliance is a nonprofit foundation. There were a lot of things informed right at the same time that WASI Preview 1 shipped in 2019. And the reason why is that it was too big of a problem to go alone. We recognized that to be able to solve this, we need to really develop something that allows us to have a modular API, because immediately after launching Preview 1, we wanted to make changes, but it was a monolithic API instead of a modular API, which is what we've landed with WASI.2. We also knew that we needed to find a way to solve this problem that the industry is facing, which is giving everything all at once, the entire environment, access to the whole operating system, just all of it, and trying to isolate it by stuffing things into container-sized boxes and then wrapping lots of stuff on top of it just isn't working. And working in that we've shipped billions of dollars of software on it, yes, but
it works, but it doesn't work.
But from a maintenance perspective, it's a huge burden from like how do I actually secure this and know that it's definitely secured perspective. It's not the right solution. And starting all the way back to that bytecode format is where you can start from the very root. And if you do it there, you don't need all of these other layers that we're adding on top. And that's why a lot of people love the idea of only targeting WASI, only targeting one WebAssembly runtime to do it. But inside the Bytecode Alliance, it was joined by organizations like Microsoft, Intel, Red Hat, Fastly, and many, many others. I think we're somewhere around 35 organizations now across the industry with a lot of research. And the things that we're so motivated to solve is how to do capability-driven interfaces. So today, if I write something in a container, I'm giving it all the environment variables that are exposed in the container, which also means all of my third-party dependencies that I installed in it for my application. So, crack open your node modules folder, all of them, they have all of that. And they have your AWS API key for whatever, your data store and all of it. So if there's any type of supply chain attack, they've got it. To a different world where I can say specifically these environment variables go to this specific component. And I can semantically analyze that before I ever even launch this thing, before I even try to run it on any given runtime. So if I'm running in a place where I didn't come up with a way to sandbox exposing sockets, then I won't execute a component that tries to expose sockets. That's very different from attacking it at an operating system level or at a network firewall type solution like with Cilium, which is compatible with, and I also recommend you do that too, defense in depth, but taking it all the way back to that first piece and allowing the platform to say exactly what is safe to run is extremely powerful. And I think we're going to see so much innovation in that space going forward.
It freaks me out, all these companies who are like, we'll have automation and AI take all of your variables and it's going to build your infrastructure for you and it's going to secure this and do that. And I'm like, I feel like you're going to have a lot of customers when they try these things that are like, let's just give the keys to the candy store to all of your infrastructure. And when that goes wrong, they're going to come and call you. Because every time I see one of these pitches, I'm like, this is a horrible idea. Why are we giving one service, the keys to your whole entire infrastructure candy store and then not being worried about what's going to happen, So.
There's a reason that we've had low-code solutions around for a decade and it's never really taken off. And I would argue that the problem to solve, the problem for these large enterprises that are building entire fleets of microservices, it's about the maintenance. It's about the burden of having written that line of code. I'm not trying to write more lines faster. I am trying to find ways to maintain what I've got and write exactly what my users need.
Yeah.
Oh, and then if you have something that's autonomously writing the code for you, you have no idea how to fix it or what went wrong with it when it goes wrong. So I'm just
I love what you said, Autumn, about the whole you're giving the keys of the kingdom to something. And if you think about it, the other pendulum swing that I always talk about is, this is obviously high level that you can dig down and there's more details, but late 90s, early 2000s is what I lovingly call the trash bag method of deployment, right? You just bundled up your stuff into you finished your app, you bundled into a trash bag and you threw it over the wall to the ops team to run your application. And then we swung in the era of Kubernetes, the exact opposite. And then everybody had to know everybody's business at all times. The developers had to know which databases and which CRDs and which credentials and which thing to use and which thing not to use and so on and so forth. And then the platform teams had to go in and say, oh, well, what dependencies are you running in this container and which things are in here? And here's this blessed template of a container. And then you have to ask for permission to do this. And then you'd end up codifying all these dependencies up. You'd end up saying, okay, well, now we have this deployment manifest. And then now we have a deployment. We have to put it in a Helm chart or in a whatever. And you're basically it's all one big blob of mess that everybody has to manage. And when you start to split these things up, you get a lot better separation of concerns. And that's why we built a platform around the standards with WasmCloud, is because we try to move that pendulum as close back to the middle as possible. If developers are programming against interfaces, it means that it's a lot simpler. They don't have to decide which Redis client they're using or which version of X thing they've got to use. They just got to decide which interface they're going to use. And then they can code against that interface. And because it's introspectable, the platform engineers can take that and say, oh, they're looking to connect to these things. And they might have a process, if it is a bigger company, say, oh, there's 3 different databases, tell us which one you want. And then they get to control those credentials. And then this kind of answers a little bit of Justin's question earlier about oh, would you want to deploy something that's global? You're able to target specific things and swap out those dependencies on the fly. and link only what you want to link and combine and re-architect the applications as needed for your platform. So you're not siloing people, but you're providing a really good layer of abstraction for the developers to say, I need X, and for the platform engineers to say, I am providing you these building blocks with these interfaces. Please use them, and then I'll take care of the details for you to connect those things, because they're the ones that those details matter to the platform engineers. They really don't matter for the most part to the developers. And so putting that back in the middle, it separates out and gets rid of that whole giving the whole keys of the kingdom to be able to do everything to all things. And that's something I really have loved about WASM, and that's why I got involved in the beginning, because that was one of my problems, having worked on things like AKS and Helm and all those kind of things in the past.
Do you ever wonder why developers are like that, though? Like, we're either like, we don't want to touch any of it, or like, we want to know every single, like, fine-grained.
It's a shared operational problem, right? Because it's like you're putting some of the operational burden, the maintenance side of it, into the development cycle. And you're saying, hey, you have to be responsible up front to tell me what access you need and all those other things. And the way we've been doing it, like you said, Taylor, with like the trash bag, like, I think of it as like my older son can do a lot of things. He has a lot of responsibilities. He does chores. He does all this stuff. But like when he gets in trouble, he's grounded. And a lot of times with like a Kubernetes application, we're like, I just need to remove all these things that you're allowed to do from your capabilities. And I see like drop all capabilities, no network access. And then we're going to add little bits back to it and try to build back up to say like, oh, you're allowed to do this much, right? And my older son's like, that's terrible. I'm never going to do that again, because I know what it's like to have all the freedom and all of the system in the world. But for my younger son, he doesn't have all those same things that he can do. And he's building up from like, hey, if I give him a couple things that he can do and say, hey, will you take out the trash for me? And also I'll let you play this video game. He loves it. And he's like, this is amazing. I can do all this stuff. And he's sharing some of the responsibility because he doesn't know what it's like to have access to the entire system and the entire world and every environment variable, right? And so like we're either dropping everything from someone that has all the access or building up from someone that's hadn't had it before and moving that to the developer and saying, you need to tell me up front what you need to do and I will give you that access in production, and then we'll both be happy as we maintain this stuff going forward.
I think it's like this pendulum keeps swinging, and I think like WASM is giving people an in the middle. It's making it more accessible for someone who doesn't have the experience, but it's also making it where you can do the things that you need to do. It's like security. Like you want something to be secure so it can't be attacked, but you don't want it to be so secure that you can't do anything with it and it's not usable. Like it's the constant, like trying to be in the middle. So it seems like you finally found a middle ground that's good and accessible.
Bailey, Taylor, thank you so much for coming on the show and describing WASI, WASM, and WasmCloud to us. This has been great and diving deep into it. If people want to find reach outs online, I know you're both within different organizations, CNCF as far as like the WASM space, and then the W3C, as well as Cosmonic.com with WasmCloud. So if someone wants to reach out, I'm sure they can find you in one of those locations. But thank you so much for coming on the show, and hopefully we'll talk to you again soon.
Thank you for having us.
Thanks for having us.
Talking to you guys was a pleasure.
What's up, friends? I'm here in the breaks with David Shu, founder and CEO at Retool. If you didn't know, Retool is the fastest way to build internal software. So, David, we're here to talk about Retool. I love Retool, you know that. Been a fan of yours for years, but I'm on the outside, and you're clearly on the inside, right? You're on the inside, right?
I think so. Yeah, I'd say so.
Okay, cool. So given that you're on the inside and I'm not on the inside, who is using Retool and why are they using Retool?
Yeah. So the primary reason someone uses Retool is typically they are a backend engineer who's looking to build some sort of internal tool, and it involves the front end. And backend engineers typically don't care too much for the front end. They might not know React, Redux all that well, and they say, hey, I just want a simple button, simple form on top of my database or API. Why is it so hard? And so that's kind of the core concept behind Retool is front-end web development has gotten so difficult in the past 5, 10, 20 years. It's so complicated today. Put together a simple form with a submit button, have that submit to an API. You have to worry, for example, about, when you press the submit button, you got to bounce it, or maybe you got to disable it when it's, is fetching is true. And then when it comes back, you got to enable the button again. When there's an error, you got to display the error message. There's so much crap now with building a simple form like that. And Retool takes that all away. And so really, I think the core reason why someone would use Retool is they just don't want to build any more internal tools. I want to save some time.
Yeah, clearly the front end has gotten complex. No doubt about that. I think even front enders would agree with that sentiment. And then you have backend folks that already have access to everything, API keys, production database, servers, whatever. But then to just stand up Retool, to me, seems like the next real easy button because you can just remove the entire front end layer complexity. You're not trying to take it away. You're just trying to augment it. You're trying to give developers a given interface, that's Retool, build out your own admin, your own view to a Google Sheet or to the production database, all inside Retool. Let Retool be the front end to the already existing back end. Is that about right?
Yeah, that is exactly right. The way we think about it is we want to abstract away things that a developer should not need to focus on, such that the developer can focus on what is truly specific or unique to their business. And so the vision of what we want to build is something like an AWS, actually, where I think AWS really fundamentally transformed the infrastructure layer. Back in the day, developers used to spend all their time thinking about how do I go rack servers, how do I go manage cooling, manage power supplies, how do I upgrade my database without it going down, how do I change out the hard drive while still being online, all these problems. And they're not problems anymore because nowadays when you want to upgrade your database, just go to RDS, you press a few buttons. And so what AWS did to the infrastructure layer is what we want to do to the application layer, specifically on the front end today. And for me, that's pretty exciting because as a developer myself, I'm not really honestly that interested, for example, in managing infrastructure in a nuts and bolts way. I would much rather be like, hey, I want an S3 bucket, boom, there's an S3 bucket. I want a database, boom, there's a database. And similarly on the front end or in the application layer, there is so much crap people have to do today when it comes to building a simple CRUD application. It's like, you probably have to install 10, 15, maybe even 20 different libraries. You probably don't know what most of the libraries do. It's really complicated. To load a simple form, you're probably downloading almost like a megabyte or two of JavaScript. It's so much crap to build a simple form. And so that's kind of the idea behind Retool is could it be a lot simpler? Could we just make it so much faster? Could you go from nothing to a form on top of your database or API in 2 minutes? Well, we think so.
Yeah, I think so too. So listeners, Retool is built for scale. It's built for enterprise. It's built for everyone. And Retool is built for developers. That's you. You can self-host it, you can run it in the cloud, custom SSO, audit logs, SOC 2 Type 2, professional services. Starting with Retool is simple, fast, and of course, it's free if you want to try it right now. So go to retool.com/changelog. That's retool.com/changelog.
Thank you so much, Bailey and Taylor, for coming on and talking to us all about just WebAssembly in general, all the stuff in the ecosystem, what WasmCloud does and how it's kind of different, and correcting me on my assumptions around like, is Kubernetes and Wasm kind of the different side of the same coin? I like being wrong, but I also like having analogies that people can relate to. So
I thought your analogies were really good, especially the kid one. I thought that was like real, like that was new levels of dad joke, like.
It's just real life for me, right? Like the more you try to take away from a kid
does
that had
this mean
access,
that we're old? That like these are our analogies? Are we old people? Like.
Hopefully the podcast listeners can relate because I don't know the age demographics, but if you don't have kids yet, you might remember when you were grounded not too long ago.
Sometimes I wish I could ground myself. Like I need a nap and I want to stay in my room and read a book all day. And like my kids complain about that. And I'm like, yo, can you do the laundry and work? And I'm going to be over here with my book.
Yeah. And don't give me about taking naps. All right.
Thank you. You are king of naps, okay? Like
love naps.
I swear I've never seen someone that naps like you do. And how do you fall asleep that fast? Like what goes on?
12 minutes. 12 minutes, all I need. It's great.
I think I would wake up more grouchy and nobody would want to put up with me, so I just keep drinking coffee.
And that's the problem. If you take a nap too long, if it's a 30-minute or more nap, you're grouchy.
How did you master this?
My kids, like I never napped before having kids, and then
you only have two of them.
I know.
The way you laughed.
It's true. I don't know how you have 3.
Why do you think I drink so much coffee, Justin? Okay, what are RFCs? Tell us what this is.
Yeah, today's outro, we're going to talk about RFCs. And if you're not familiar with them, they are, it stands for Request for Comments. And it's part of the IETF, which is like a standards body that has been around for a very, very long time. And RFCs have been around for, I believe, 50 years now. I forgot to look up what the first RFC was. But if you like ASCII diagrams, you're going to love RFCs.
Justin, who wakes up and says, I love ASCII diagrams? They just make me happy.
A good ASCII diagram. Look, I have a GitHub repo called Awesome Tuies, which is basically like functional ASCII diagrams. Like, that's all it is.
You collect GitHub repos like other people collect domain names, okay? Like, I don't know if you collecting...
GitHub repos are cheaper.
You know what? You're not wrong. Maybe you're doing it the correct way.
But I was reading RFC this last week. I don't remember. Did I tell you what I was reading on? I don't remember what it was.
I don't remember. But all I know is you were like, I like white papers. So when you come up with white papers, I get excited. This, I'm like a little bit scared. Like,
I don't know when I got into white papers. I got into white papers before I got into reading RFCs. RFCs are for me like, I need to debug something.
I got into white papers when I started reading them for work at AWS. And then I just like, it became like my favorite way to consume things. Like if I'm at a study for a certification, like I will read a bunch of white papers on like that technology first, because I hate like, I definitely like watching like video classes and all that stuff in books, but sometimes white papers gets you to the point.
Yeah. I mean, it's long-winded sometimes, but it helped me. I started reading white papers when I had my first sysadmin job because I was learning all these technologies I never had access to before.
Yes.
And the best thing about white papers was it told me when to not use a technology.
But that's what, like, really, when you're trying to learn something new, that's what, especially like from the context of a solutions architect, which is where I started reading papers, I want to know what the use case is. When do I use this? When do I not use it? How does this compare to something else? And like
that has helped me so much in my career. Like meetings where they're like, hey, we're talking about this new technology. We want to use this new thing. And like, we think we can apply it to this domain. And I would like read the white paper. I was like, hey, in this white paper, they didn't use it for these reasons. And do we have similar constraints? Should we be doing those things? And that has served me very well. And I enjoyed reading them.
It helps you not get tech debt for nothing, because people are like, this is the new fancy thing. And you're like,
Yeah, well, I've seen this before. Right?
Yeah.
and there's a lot of white papers that are not technology related at all, or they're technology adjacent. When I was at Disney, I loved reading the Pixar animation and Disney animation white papers because they were just papers I could put out. Most of them were not systems related. They were rendering. They were like, we had a white paper at Disney that was like how to render snow accurately for Frozen, right? Like there was a whole like research thing. There's a research team at a lot of these studios.
Really cool.
A lot of the special effects companies will have research teams that will do this like deep research, and then they write a white paper and say like, this is what we found.
How do you get a job on making snow? That just sounds fun.
But and like RFCs are kind of the other end of that, right? Where like research papers and white papers are like when do we apply things and how the technology works, and white papers or RFCs are kind of the like, this is a spec of a thing that we want to exist and we want people to adopt it for some way. And it's not like a set in stone thing, because plenty of RFCs replace older RFCs or augment them and say, hey, we tried this thing and maybe it didn't work so well. But some of the ones are like very foundational technologies like DNS and IPv4 and IPv6 and some things that people probably aren't familiar with anymore, like BootP. BootP was like a precursor to DHCP. It was like DHCP is also an RFC, but like BootP was like the original. Like, hey, you plug in a thing into a network of systems and you don't want to configure it manually. How do you get that configuration?
I love that though, because I feel like a lot of when you're really solving hard problems in technology, like you know that you want to build something, but learning like that what the blocks are. Like sometimes you know that you want to build something, but you don't know what's available to help you build it, right? So like knowing what the Lego pieces look like it's like building Lego pieces in the dark until you know what tools are out there for you to build, you know? So
speed building Lego pieces in the dark sounds like
it's hard. It's not fun. So it's like, watch, Tech's gonna have that as an interview process. If you want to be an engineer, no.
New leak code. Millennium Falcon, we just poured it out in this room. Don't step on the pieces.
No instructions. Like
barefoot.
we wanted it in an hour. No, but like, so I feel like when you have white papers, when you have like any kind of that helps you to understand the tools better, for you to understand how to build these things and to be able to use the tools better and more efficiently, always makes you a better engineer or builder.
And the times I have used RFCs have been the times I've been taking a system apart. Right? Like white papers help me build it or know which technologies to build it. RFCs help me understand it when I need to dissect it and say like, oh, what's the header for this IP packet, or what's the like protocol I'm looking for, or what's the flag, like that stuff. Looking at the specs has been super helpful. That's what it was. I was looking at tunneling protocols, a white paper about tunneling IP and IP, and it was like, I went down this rabbit hole. I was watching TV one night and pulled it up, and that's what I do for fun.
I love the rabbit holes that you randomly go through, and then like I get a signal or a text message of some random like thing, and it always makes my day. Yes, but like, dude, I was reading a meme, and it said being friends or having loved ones who are ADHD is like microdosing like Wikipedia, and like, is that not our conversations?
But we go far enough to like, we're off of Wikipedia right now. We're in the Wikipedia resources. Yeah. We found the resources of the resources.
We've gone down the rabbit hole.
I found the bottom of this hole. Guess what? It's bash. Everything just runs on bash.
It's always bash. It's bash and assembly, and it makes the world like go round.
Yeah. So yeah, no, we just wanted to call out like RFCs in general. We'll have a link in the show notes.
Okay, so what's the coolest RFC that you like? Give us like two really cool ones that you were like, I did not know that, or that like made your day.
I mean, the 2068 is HTTP protocol, like first gen a 1.1 or whatever. 2068 is a really foundational one if you're like trying to understand how verbs work and how HTTP is supposed to work in the real worlds. Ones that I remember reading were the TCP and IPv4. So that's TCP is 793 and IPv4 is 791. So like around the same time, right? That's like two off. Like IPv4 is 791, ICMP, which is ping packets, 792, and TCP 793. Like they go in order of like when these things are being ratified and kind of created. And it's like, hey, we need to have IP addresses, we need to have ping packets, and then we need TCP. And that's like,
this is a really nice little summary and kind of like list of things, and I like this.
Yeah, we're gonna link to the one from Wireshark. Had a really good like roundup of some of the foundational ones for network stuff, which is a lot of RFCs.
Do you feel like that like networking sometimes feels like Charlie Brown's teacher talking to you until you go down like 5 rabbit holes and then you kind of understand the first thing, but then you're confused about 2 other things after that?
I mean, if you like acronyms, then be a network engineer.
I'm always like, okay, I know the first thing that I wanted to know, but now I'm confused about 5 other things, and like it's been 4 hours.
I mean, the best thing is just to like try to pronounce all of the networking acronyms, because like at least with like Kubernetes,
nobody told me there was so much math though. Like
yeah.
Why? Like I was just like I was in Tech U, I think, when I was learning how to be a solutions architect, and dude, they were like, and then we're going to do this math, and I'm like, whoa, networking and math. I was like, too far. Whoa.
Matt, you just reminded me that I read a white paper, which was probably one of my favorite white papers, which was like one of the early software-defined networking white papers. And for the life of me, cannot remember what the title of it was. If any of our listeners know the foundational like software-defined networking, I remember where I was when I read it. I remember like I used to print them out and like go mark them up. I would read them at lunch. I'd bring a Sharpie with me. I'd write notes, and I basically recycle them.
You are my favorite type of like hyperfixation nerd. Like I just like, no, but okay, be real. Friends that you can have fun conversations and then learn something with and make things not so daunting are like the like secret to like life. Okay.
Oh yeah,
like,
and having friends that are experts in very like
yes,
like very specific things. Like, hey, what like cosplay, like 3D printing cosplay, like how do I do this piece, right?
Well, not just that, but when somebody asks me Kubernetes questions, I'm like, hold on, let me text Justin. like I don't think the idea that you have to be an expert at everything in tech is like just a pipe dream. You are not going to know all the things. Everything's constantly changing, but knowing the right people to ask to find out, that is like
one of the things that I think in developer relations and DevRel that I've done fairly well is I don't have the answers, but I know who to connect you to. And that is a huge win.
I think that's real in engineering, though. Like, not even just dev real. Like, I think like you can help your and solutions architect. That's basically what a solutions architect is. Yeah. They might like you are either the expert specialist who knows that area deep, or you are the generalist that knows all the specialists to talk to. Like,
and a lot of it's just like helping someone sidestep the process of like filing a ticket, or like, right? Like that's the whole point. Like, hey, we have someone that is important.
Essays can't do that, but maybe like a TAM and an account manager, maybe. But you got to have really good TAM and account managers, and I think having the people skills to talk and be nice to those people and to build good relationships, that's how you get your customers the best results. When you know the people to find to help them if they have a problem that you can't answer, and you've built good relationships with other humans to get them what they need, you know?
Agreed. So anyway, we wanted to call that out because that was something that I did this week, and it wasn't something that is commonly known, at least not in like, at least from what I know of like the current market of people coming into tech and learning about things. Like, how do I find the source of this? And you always find like the person that's worked there for 10, 15 years and like, oh, they know. But actually like there's like a database that's free. And one thing I love about RFCs is they're free. They're like, it is open, available to public, where a lot of white papers are not. It's like you have to subscribe or know something. Or be...
Not just this, but this gives you like a great starting place for a lot of different things that will help you to kind of have a better understanding of networking, which is a daunting task when you're first learning about it, you know?
Oh, for sure. Yeah. Just networking is very deep, and no one knows everything.
And I think knowing the TCP layers and just certain things is just a really good, like if you're going to deal with cloud and other things, like it's a good, just to have a good, 100 level, 200 level, just to kind of understand what you're reading when it comes to like VPCs and all that good stuff.
Yeah. It's just the same stuff in a new envelope.
It is. And then when you start at a basic level like this, you're more equipped to go into a more, I guess, you know, the new shiny versions of it.
So thank you everyone for listening. If you have a topic you'd like us to talk about, or someone you'd want to come and be on the show, feel free to email us. It is shipit@changelog.com. And hopefully we will see you around. If I know I'm traveling, or actually, I don't know when this episode is going out. I think it'll go after my conferences, but there's conferences in the fall that we're going to as well. So there's some times to meet us if we are in person. We like to interview people in person when possible. And yeah, we'll talk to you all soon. 3, 2, 1.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.